Now let's take a look into how we balance equations. All right, so we balance equations to satisfy the law of conservation of mass. So basically, when I have an ordinary non-nuclear reaction, whatever I put in is what I should get out. So if I look here, I've got a couple of hydrogen molecules, an oxygen molecule, and I get 2H2O. So what I have is 2H2 means I have a total of 4 hydrogens, and O2 means I have 2 oxygens, okay? And then when I look at the other side, I have 2H2O. So 2 times the 2 hydrogens gives me 4 hydrogens, and then 2 times the 1 oxygen gives me 2 oxygens. So on my reactant side, I had 4 hydrogen atoms in some arrangement and 2 oxygen atoms. On my product side, I have 4 hydrogen atoms in some arrangement and 2 oxygen atoms. So this is balanced. Okay, now keep in mind that we do have our state designations. So a correct equation is going to be denoting whether something is a gas, a liquid, a solid, or aqueous. And again, aqueous is dissolved in water. Now for liquid, that lowercase l, when I write the lowercase l, I was taught to write it a cursive lowercase l because the chemist that taught me said that this looks too much like a 1, which it kind of does. So from here on out, you will see that I write all of my liquid designations with a little cursive L to make sure that I don't look at it and think I've put 1 in parentheses for some reason. Okay, so if I were to take a look at an equation like this, so zinc and hydrochloric acid gives me zinc chloride and hydrogen gas, I would count up everything there. 1 atom of zinc, 2 atoms of hydrogen, 2 atoms of chlorine, 1 atom of zinc, 2 atoms of chlorine, 2 atoms of hydrogen. That balances. Now, if I were to look at the masses of all of these, a zinc atom and 2 molecules of hydrochloric acid have a mass of 138.30 grams if I have 1 mole of each substance. Now, if I have 1 mole of or 2 moles of the hydrochloric acid because of the coefficient in front of it. And on the product side, I have 1 mole of each substance. I have 1 mole of zinc chloride and 1 mole of hydrogen gas. Well, if I look at the mass of 1 mole of zinc chloride and 1 mole of hydrogen gas, I get the same mass as I did of 1 mole of zinc and the 2 moles of the hydrochloric acid. So we balance to satisfy that law of conservation of mass. Okay, and so here I've got some magnesium, some oxygen gas combining into magnesium oxide. So I have 2 magnesium on each side and I have 2 oxygens on each side. Now, sometimes you'll be given a skeleton equation. Other times you will need to translate what is written into a skeleton equation. So if you have that, you translate that to a skeleton equation, then you balance your atoms. It's usually a good idea to start with what looks more complex and then to boil it down to what's less complex and then adjust your coefficients and then double check. So let's give it a shot. All right, so we have group 1A elements. We're going to take some sodium. They react violently with water. We're going to form hydrogen gas and sodium hydroxide solution. All right. So, chunks of sodium, that sounds like a solid to me. Okay, react violently with water. So water is a liquid. Okay, we're going to form hydrogen gas. Here remember that hydrogen's a diatomic, so it's H2, and sodium hydroxide solution. Solution is aqueous there. Okay, so what I can do is as I start to balance this, I can start kind of keeping a ledger of things if I need to. So right now what I have on my reactant side is 1 sodium, 2 hydrogens, and 1 oxygen. On my product side, I'm going to keep it in the same order. So I go to my product side, I have 1 sodium. I have 2 hydrogens, 3 hydrogens, because I have my H2 and then the hydrogen in the NaOH. So I have 3 hydrogens, and then I have 1 oxygen. So 2 hydrogens does not equal 3 hydrogens. So we're going to have to do some balancing here. Now, one thing to keep in mind is that I have that H2 over on the product side. So anytime I put anything in front of an H2, it's going to be an even number. Same thing over on my reactant side, I have H2O. So no matter what I do on my reactant side, I'm going to end up with an even number of hydrogens. Okay, so let's say I were to put a 2 in front of that. What that's going to adjust to is I'm going to get 4 hydrogens and 2 oxygens, okay? All right, well, 4 still doesn't equal 3, and 2 doesn't equal 1. So is there a place on my product side where I could increase the number of hydrogens by just 1 and also double the number of oxygens? There is, because in my sodium hydroxide, I have 1 oxygen and 1 hydrogen. So if I put a 2 in front of my sodium hydroxide, what I get, now I have 2 hydrogens from the hydrogen gas and 2 hydrogens because I have 2 sodium hydroxides. Okay, so whatever coefficient is in front of something goes out to everything in that particular species. Okay, so 2 in front of sodium hydroxide means 2 sodiums, 2 oxygens, and 2 hydrogens. 2 in front of water, 2 times 2, because I have H2, I have 4 hydrogens and 2 oxygens. Okay? All right, now 2 times the 1 oxygen is going to give me 2. But now what I have is 2 times that sodium, so I also have 2 sodiums. Now, this is where I was saying balance the least complicated, balance the easiest last. Because if I look at this, well, I have sodium all by itself over there on my reactant side. Nothing duplicating it, it's just monatomic, so it's easy. Whatever happens to my sodium on the product side, I can do on my reactant side. So I can put a 2 over here, and voila, 2 sodiums equals 2 sodiums, 4 hydrogens equals 4 hydrogens, and 2 oxygens equals 2 oxygens. So this one is balanced. Let's try another one. Okay. All right, so acid rain. Acid rain destroys marble statues because there's a reaction where when something acidic hits what marble is made out of, we end up forming some gases and some liquid water and an aqueous solution that just washes away. So we're going to get some aqueous nitric acid. So nitric acid is our HNO3. Okay, reacts with calcium carbonate. Oh, that was interesting. Okay, and marble statues, that's our calcium carbonate, so that's probably solid. All right, we're going to get carbon dioxide, which we know is a gas, water, and aqueous calcium nitrate. Okay, all right, so now one thing I can do is if I look at nitrate, okay, nitrate is NO3. Well, I've got an NO3 there, and I've got NO3 there. So one thing that can help when you're balancing, if you have a group of a polyatomic ion like that, is you can kind of balance by inspection. So if I have 2 nitrates on my product side, I'm probably going to need at least 2 on my reactant side. So I'm going to put a 2 here, and then I'm going to go through everything. So I have 2 hydrogens over here. Okay, on my product side, I only have hydrogen and water, so now I have 2 hydrogens. All right, now I'm going to leave the nitrate together, okay? So I have 2 of the nitrate. I have 2 of the nitrate. All right, so we're going to count those oxygens as just part of the nitrate, so I'll highlight that so you know that we are counting that separate from the rest of the oxygens, okay? All right, now I have 1 calcium over here on my reactant side. Looking at my product side, I also have 1 calcium. Okay, I have 1 carbon over here in my carbon dioxide. That's the only place where carbon shows up, so I have 1 carbon. And then in my calcium carbonate, I have 3 oxygens. Well, when I look at the product side, I have 2 oxygens in carbon dioxide and 1 oxygen in water. So I do indeed have 3 oxygens. Okay? So here's the thing about equation balancing. You have to practice it. All right? So that being said, the next set of slides is for you to practice on your own. All I will do is give the final result for them. I'm not going to go through the whole process of balancing it for you in each of those, because you can write down what I do until the end of time, but that's not going to help you when it comes time to actually needing to replicate what we're doing here. So the next set of slides are for you to practice on your own. So I would recommend practice those first, okay? And then you can open up the equation balancing practice video and see if you manage to get your answers correct. So I split equation balancing up into 2 videos, one to show you how to do it and one for you to practice all the balancing on your own, okay? So try the balancing and then open up the next video that shows you the answers on all the extra practice problems.